All right, welcome to day one of the new unit, so unit 6. Homework will be packet page 5 and 6. Now, on the inside cover of your packet, notice you have a whole bunch of formulas. Basically, the left side of that formula sheet, those are the ones that we use in geometry. So we will talk about a few of those today, basically the top like 3 or so, and then the other ones on the left side we'll get to at different points in this unit. Um, so for the homework for tonight, you can always, if you need the formulas at all, you can always flip to that inside cover. So you have that as a resource as you are doing various problems throughout the unit. You will be able to use this formula sheet on quizzes and tests in the unit. I will provide you a separate copy of it so that you won't have your packet out during the quiz or test, but I'll give you a clean copy so that you have that to use. So packet page 1 is not that formula sheet, it's actually the next page, and we're just going to go through some of those area formulas. So the circle area formula you actually have on the reference sheet, but for circle, area is equal to pi times radius squared. And just a reminder, the radius of the circle is only halfway across. If you were going all the way across, that would be the diameter. Your parallelogram is also on that formula sheet. The area of a parallelogram is just the base times the height. Now, keep in mind, when we're talking, that's the base, but when we're talking the height has to be a straight up and down height, forming a right angle. So next we'll go to triangle, which is also on that reference sheet. So area for a triangle is 1/2 base times height. Again, remember that height has to be perpendicular to it. And those are the three from the reference sheet that we will use today. Some other ones. A rectangle area is also just base times height. You can think of it as length times width if you wanted, but it's the same as saying base times height. And some you might not remember as well. The trapezoid is 1/2 times the height times the sum of base 1 and base 2. So maybe this is base 1, this is base 2. Your height has to be the straight up and down height, just like everything else. And a kite is basically like two isosceles triangles, so something like that. And your area formula for a kite is diagonal 1 times diagonal 2 over 2. So diagonal 1 would maybe be that whole thing. Diagonal 2 would be that whole thing. So we will use those in problems today. So you'll use them on the homework, so you'll want to keep those handy. So if we go to the bottom of page 1, first thing we want to recognize is this is a trapezoid. It's always helpful to just write the formula first. You saw up above our trapezoid formula was 1/2 times the height times the sum of base 1 plus base 2. So that'll be 1/2. Now our height is just the distance between the bases. So this one is kind of turned. So this would be our height here, the 180. Then parentheses, we'll have 200 plus 350. And we'll pause for a moment to allow you to punch that in your calculator. And then note your units. We have meters right now, so see if you can think about what your units would be after you write that down. So again, we'll give you a moment to punch that in. So you should have gotten 49,500, and it's an area, so our units need to be squared. So we should have meters squared. In B, we've got part of a circle. Well, the area of a circle is pi r squared, but that's for a whole circle. So we need to think about what portion of a circle do we have. Well, 90-degree angle chunk has been chopped out. So basically a quarter of it has been removed, so we still have 3/4 of the circle left. So this is going to be 3/4 pi times our radius, which they told us was 4, and then squared. Well, notice it nowhere in the question says we should be rounding. If it does not say to round, you should never round. So what that means is if it's in terms of pi, keep it in terms of pi. So what we'll do here is we're going to get an answer that'll just be some number with a pi on the end. So if we do 4 squared, that'll give us 16. 16 times 3 is 48. Divided by 4 will give us 12. So this is just going to be 12 pi units squared. Now, you didn't have to do that by hand. We could do it in the calculator, but when you do it in the calculator, don't put the pi in. So you would do 3/4 times 4 squared. That would give you the 12, and then you just stick the pi on afterwards. This is an exact answer. Okay, if you put in the pi, and even if you write down all the decimals, that's still a rounded answer because it would go on forever. So do not round if the question does not say to round. All right, if we go to the next one, notice we've got markings for all congruent sides. So we know that this has to be 50. And if this is a right triangle, we can do Pythagorean theorem. So let's call this x, and we'll have 40 squared plus x squared equals 50 squared. Well, this would be 1600 plus x squared equals 2500. We'll subtract the 1600 over. So we got x squared equals 900. We can take the square root, and when we do that, we'll get x equals 30. So this length here is just 30. Well, if this is 30, 40, and 50, the other triangle must be 30, 40, and 50. And if these are 50s, this must also have to be 30. So what we're going to do is we're going to do the area of this triangle, and we're going to double it because there's 2 of those triangles. So our area is going to be 1/2. Our base of that triangle is 80, and the height is 30. But that just gives us for one of the triangles. If we double it, it'll give us for the whole figure. Well, 2 times 1/2 is just 1. 3 times 8 is 24, and then tack the 2 zeros on. So we'll get that our area is just 24, and we'll have inches squared. Well, here's our first example of a kite. We had that a kite's area formula was just diagonal 1 times diagonal 2 over 2. And it's that entire diagonal that you have to use. So the vertical one is just 9. And I should specify a diagonal goes from a vertice to a vertice that is not next to it. The other diagonal would be those 6's put together, which is 12, and then over 2. Now, if you wanted to do this in your head, you could do multiplication or division in any order. So you would want to do the 12 divided by the 2 first to get 6, and then 6 times 9 would give you 54. So this is going to be 54 feet squared. You don't have to do it in your head. You can do it right in your calculator, but it's good to just think through those things because there will be things where you're not allowed to use a calculator. For example, a third of the SAT is no calculator. Next one, we just have a triangle. Hopefully this one is somewhat straightforward. We have 1/2 the base times the height. So that's just 1/2 times 30 times 13. And we'll give you a moment to punch that in your calculator. And we should get 195 centimeters squared. All right, so those are basic figures, ones that are just a single figure. Next up, we're going to look at what's called composite shapes. In composite shapes, we basically have those basic figures, multiple of them stuck together. And what we do is we just split them into more convenient shapes. So we're going to draw a vertical line down there, and we're going to call this section area 1 and this section area 2. And what we'll do is we'll see if we can find those two areas, and then we'll just add them together. Well, area 1 is just a rectangle. We can just do base times height, so we'll have 16 times 12, which when we punch it in will give us 192 centimeters squared. So that's the easier of the two. Well, the triangle, we need to know the base and the height, and they should be perpendicular to each other. Well, we already know that this is 12 from the other side of the rectangle. They tell us that this whole thing here is 24, and this part of it is 16. So therefore, the height in the triangle should be however much 24 is beyond 16. So 24 minus 16 will give us that that is 8. So for area 2, we'll have our triangle 1/2 base times height. So 1/2 12 times 8. So if you're going to do this in your head, you want to do half of 12 first, and you'll get 6. And then 6 times 8 gives you 48 centimeters squared. Well, now we want to find the total area, so we'll just add those together. If you add our 192 and our 48, that'll just give us 240 centimeters squared. So the idea of composite areas is split it into areas that we have a formula for. All right, the next one, we can split this into a trapezoid and a half circle. So let's maybe call that area 1 and this area 2. So area of a circle is pi times radius squared. But we only have half a circle, so we're going to put a 1/2 out front. So we'll have 1/2 pi. Now, one of the most common errors that people make in areas of circles is putting in the diameter instead of the radius. 30 is our diameter because it goes all the way across. So our radius would just be 15. If we do 15 squared times a half, we would get 112.5, and then we also have a pi, meters squared. So a couple things I want to talk about that 112.5 pi meters squared. It did not say to round anywhere. That's why we just left it in what's called in terms of pi. That is an exact value. If it said to round, then we could put the pi in our calculator, but it did not, so we don't want to put the pi in. The other thing, the 15 squared times the half, you could have also left that as 225 over 2. If when you divided by 2, it had not been a terminating decimal, so say it had had like a 0.3 repeating forever. If that's the case, then you cannot leave it as the decimal. You would want to do a menu number factor and put it back as a fraction. But because when we divided by 2, it was a terminating decimal, it is okay to leave it as the decimal. So either the 112.5 pi or the 225 over 2 pi would be correct. Now for area 2, we have a trapezoid. So we'll have 1/2 our height, which was 15, times the sum of our bases. Base 1 was 48 and base 2 was 30, and you can interchange those bases. It doesn't have to be in that order. And when we punch that all in, it comes out to a nice 585 meters squared. For our overall area, we just need to add those together. 112.5 pi plus 585. And we'll throw meters squared on the end. Now, one of those has a pi and one of those does not. So they are not like terms. We cannot combine them. This is our final answer. Okay, this is an exact value. Again, you should never, ever, ever round in a question if it does not tell you to round. Okay, if you're getting something that's not nice and it didn't tell you to round, you should be thinking in terms of pi, or sometimes we've seen problems earlier this year where you need to leave things in radical form or fraction form. But you should never, ever round if the question does not tell you to round. All right, so let's extend this composite figure idea. So we've got James, he needs to carpet the floor of the room that's on the left. How much will it cost if the carpet is $275 per square foot? So let's find out how many square feet there are. We can split this into 3 shapes. We'll call it area 1, area 2, and area 3. So in area 1, our triangle, we have 5 and 5 on the bottom. It tells us to give us 10 for this. Well, if this part is 2, that means just this would be 11. And if here to here is 15, subtract the 11, and that would leave us 4 for that part. So for area 1, we'll have 1/2 our base times height, so 1/2 4 times 10. Half of 4 is 2, so we'll get 20 feet squared. Next up for area 2, it's just a rectangle, so a base times a height. We have a base of 10, and we had a height of 11. So we've got 110 feet squared. And then area 3 is also a rectangle. We've got a base of 5 and a height of 2, so we'll just get 10 feet squared. To find our overall area, we'll just add those all up. And that'll give us 140 feet squared. Well, that's not what we wanted. We wanted to know the cost. So we're going to do lots of unit conversions eventually in this unit, and we'll start to kind of show them to you now. So we have 140 feet squared. And we were given $2.75 per square foot. Per just means divide. If you hear miles per hour, it means you did miles divided by hours. So if we want to convert this and know how much money it is, we'll always multiply by a fraction. Now feet squared right now is in a numerator. The next time feet squared shows up, it needs to be in the opposite spot of the fraction. Well, it told us we're going to do $2.75 per square foot. Well, per 1 square foot means we're working with 1 there. So we're going to have 1 foot squared on the bottom, and we'll have $2.75 on top. Well, a feet squared is on top, a feet squared is on bottom. So if we multiply this now, we will end up getting a dollars amount. So I don't expect you to understand the unit conversion type thing we're doing right here yet, but we are going to do it a lot in this unit, so I want to make sure I'm consistent in how I'm introducing it to you, so you will recognize it after we do it a couple of times. So in our calculators, we now want to do 140 times, and you can just do 2.75, because if it's over 1, it doesn't change anything. And this would give us 385, and our units that is left is dollars. Okay, last one for this video. Hilda broke the unusually shaped picture window in her parents' living room. The figure shows the dimensions of the window. Replacement glass costs $8 per square foot, and there will be a $35 installation fee. Find the cost to replace the window to the nearest cent. Well, if it's $8 per square feet, first thing we want to do is we want to find the area. So we're going to make these triangles here, and then we'll have a half circle and a rectangle. So in our triangles, if this base down here is 3 and it was 5 all the way across, that means these are each 1. So we're going to have, for our area of our triangle, 1/2, 1 times 1. So that's going to give us a half, but we have 2 of those triangles. So we'll double it and we'll get 1 foot squared for the 2 triangles. We'll maybe call area 2 the rectangle. We have a base of 3, and then the height is actually 5, because you've got the 4 here and the 1 there. So we'll have for area 2, 3 times 5 is 15 feet squared. And for area 3, and again, area 1 was both of these two combined. Area 3, we have half of a circle. So we'll have 1/2 pi times our radius squared. Well, all the way across is 5, So half of that, you could either do 2.5 or 5 halves. If we square that and multiply by a half, keeping it in terms of pi, we'll have 3.125 pi. So the pi just stays on the end, okay? Because we are going to round here, but we don't want to round to the very end. So if we add each of these up, 1 plus 15 gives us 16, plus the 3.125 pi, and this is going to be feet squared. Well, we want to multiply that by our $8 per square foot. So we're going to again put 1 foot squared on the bottom times the 8 on top. So if you punch that in the calculator, one thing we have to be careful of is we want that all in parentheses. We want the whole thing multiplied by 8. So we are going to put the pi in this time because we are going to round. So everyone take a minute, put in parentheses 16 plus 3.125. Now the pi button is down on the bottom left. You'll hit the pi and then a menu will pop up and you can select the actual pi. Close your parentheses and then times, we're going to do times the $8. And the reason we'll know we'll end up with dollars is because you had feet squared both top and bottom. And we should be getting 206.539 and some other stuff dollars. But there was also the $35 installation fee. So we've got to add the $35 on, and that'll give us 241.539 and some other stuff. And this one told us to round to the nearest cent. So we'll look at the 9, which is in the thousands place, because cents is 2 places. And because it's 5 and above, that'll bump us up. So we'll have $241.41. All right, that's it for this video. Have a great rest of your day.